So we've always heard that atoms are like ridiculously small. For example, if a grapefruit would be the size of the Earth, an atom would just be the size of a grape. There's like 7 billion atoms in your body. They are so ridiculously small, it's stupid. I think there's kind of this vibe between like macroscopic and microscopic. That's things we can see with like our eyes and microscopes, versus like the atomic and subatomic, which is the size of atoms and their nucleus and electrons and all that stuff. I think people kind of see these things as two separate worlds. That's not really true, and there are some ways they interact. They interact in something called Brownian motion. Now, there was this guy called Brown. He wasn't the first to discover it, but he was the first to be like, hey, something's going on here. I don't know what it is, but something's up. He was taking a look at pollen under a microscope, and he realized it was moving, which is very weird and should not happen. It was kind of like shaking a little bit. But how is that possible? And it was basically a mystery until our good old pal Einstein came along. And he said, imagine pollen, something so small we need a microscope to see. For it, atoms are still much too small, but they would still be able to have some effect. So imagine this is a piece of pollen. It's microscopically small. And all around it in the air is this soup of atoms. And those atoms are constantly hitting this ball of pollen. Now, in real life, there's like millions on one side and millions on the other, so it just kind of balances out for this thing. But if we imagine this as a piece of pollen, say there's 99 collisions on one side and 104 on the other. That's not a lot, but it's enough to move the pollen a little tiny bit. Do that again, and suddenly there's more on one side, so it moves in that way. Repeat that over and over and over again, and you'll get a little jiggle in the pollen.